For the longest time, the delicate world of arts and crafts has felt like a uniquely human thing. But a pretty recent breakthrough is giving robots a sense of touch that's so precise, it's really starting to challenge our whole definition of what an artist even is. I mean, just imagine it for a second. A machine with the kind of finesse to handle the most fragile materials, to create something intricate and beautiful with its own hands. For decades, this was pure science fiction. Well, until now. At the massive CES tech show, a humanoid robot they named North autonomously assembled a complete, delicate paper windmill from scratch. That's a task that requires just an incredible level of dexterity. So let's take a closer look at what actually happened here. How did a robot finally achieve a level of dexterity that has, frankly, eluded engineers for decades? This was not a simple task. Not at all. It involved handling super thin, deformable paper without ripping it, making these perfect folds with sub-millimeter accuracy, and then the really, really difficult part, inserting tiny little pins into this fragile structure. This whole process required over 30 consecutive, delicate steps. So yeah, the big question is, how is this even possible? It's one thing to see it happen, but the real story, the amazing part, is in the technology that made it all work. And the answer starts with the hardware. Let's look at the hand itself. This is really the core of the whole breakthrough, and it was developed by a Singapore-based company called Sharpa. So the SharpaWave hand is designed to be just like ours. Anthropomorphic just means it's built on a human scale. It has 22 degrees of freedom, which is a fancy way of saying it has 22 different ways it can move, allowing for these incredibly complex finger movements. But here's the real game changer. This number. Over 1,000. So what does that represent? This right here is the giant leap forward. Each fingertip on the SharpaWave hand has over 1,000 tiny sensors. You can just think of them as tactile pixels. This is a fantastic example of biomimicry in action, right? Engineering that mimics biology to give the robot this powerful sense of touch. It can feel texture, it can feel softness, and it can adjust its grip in real time so it doesn't crush something as delicate as a piece of paper. And the difference this makes is just stark. Traditional robot grippers are rigid, they're clumsy, and they operate without any real sense of feel. The SharpaWave hand, on the other hand, is dexterous and adaptive. It actually feels what it's holding and responds in real time. But look, an amazing hand is nothing without a brain to control it. And that's where the software comes in. It's called CraftNet, and it's the thing that turns that sense of touch into intelligent action. CraftNet is the AI that pilots the hand. It's an end-to-end model, which basically means it takes in this flood of information from all its senses and uses it to plan and carry out these long, complex sequences, like, say, building that 30-step windmill. So how does it think? Well, it uses what's called a VTLA model. It combines vision to see all the parts, tactile feedback from the hand to feel the material it's working with, language instructions to understand the goal, and finally, action planning to execute every single step. And that is the crucial combination. The sensitive hand provides all the data, and the smart brain interprets it. This is what allows the robot to adapt when things don't go perfectly. If the paper slips a little bit or a fold isn't quite right, it can adjust on the fly just like a person would. Okay, a robot building a paper windmill is an incredible demonstration, no doubt. But what does this mean for the real world? This is where we start to see the bigger ambition behind the technology. This is Sharpa's core mission. Their goal is to manufacture time by creating robots that are genuinely useful in our daily lives. This isn't just about automating another factory line, it's about bringing robotic assistants into more human-centric fields. And this just opens up some truly fascinating possibilities. I mean, imagine a robot as an art therapy assistant providing steady, gentle guidance for a patient, or as a tutor, patiently showing a child how to build a model. Economically, this could totally revolutionize custom craft production, allowing for personalized, intricate goods at scale. And maybe most importantly, it could become this powerful accessibility tool, allowing people with motor impairments to create physical art just by giving instructions. This technology is clearly transformative, but, as with any major leap forward, it brings with it some profound new questions that we really need to start thinking about. Questions about creativity itself. So here's the first one. If a robot is just executing a set of instructions, even with incredible skill, is the result still art? Where does the creativity actually lie? Is it in the design or in the execution? And that leads to an even deeper question. At what point does a sophisticated tool become a collaborator or maybe even a creator in its own right? We've used tools to make art for thousands of years, but this feels different. Look, right now, the technology is all about execution. North, the robot, isn't inventing new windmill designs, it's just following a plan. But what this achievement does is seriously blur the boundary between cold mechanical precision and what we think of as warm artistic finesse. And this leaves us with a critical question for the future. As this technology evolves, will these dexterous robots become partners that augment our human creativity? Or will they one day replace it? The answer isn't clear at all, but the conversation is definitely just beginning.